Okay, so what we're going to look at today is factoring quadratics where a is 1 and difference of squares. And so up until this point, we have factored by grouping, which is when you have 4 terms. We factored using a GCF, which can be 2 terms or more. And GCF is the thing that you always, always, always want to do before doing anything else if you can. So today's no different. When we're factoring a quadratic of the form x squared plus bx plus c, you always want to check to see if there's a GCF first. And so technically in front of that x squared is an a, but for all of the ones we're going to do today, a is going to be 1. And so if you look at this first example, we've got x squared minus 8x plus 12, and technically there's a 1 in front of that x squared. And we're going to first write the polynomial in descending order. So that's according to its exponent. So x squared comes first, 8x comes next, 12 comes last. So we've got an exponent of 2, an exponent of 1, and an exponent of 0. Then we're going to find 2 numbers whose product is a times c and whose sum is b. So we're going to assume that there's a 1 in front of that x squared, and we're going to multiply that a value of 1 times our c value, which is 12, and put it in this little organizer over here. And a times c goes on top and b goes on bottom. And so the next step is we're going to find 2 numbers whose product is a times c and sum is b. So multiplies to give you 12, adds to give you negative 8. And so think of all your factors for 12, so 1 and 12, 2 and 6, 3 and 4, and see which of those could possibly give us negative 8. And hopefully you find that it's negative 6 and negative 2. And so when we write it in factored form, all we have to do is use those numbers and write it with our factors. So x minus 6 and x minus 2. And so what we're going to do next time is we're going to factor those trinomials by grouping. And so we can do it with these, but it's a little bit longer of a process, and so we're just going to skip straight to the x minus 6, x minus 2. So if we look at example 2, we've got x squared minus 56 minus 10x, and first things first, we want to write it in descending order. So we'll have x squared minus 10x minus 56. We want to assume, because we are smart, that there's a 1 in front of that x squared, and we're going to multiply it by that negative 56. So a times c is negative 56, and b is negative 10. And so we want to think of all the numbers we know about that multiply to give me negative 56, but add to give me negative 10. So that one's a little bit tricky because the typical ones we know for 56 would be 1 and 56. Well, that can't give me negative 10. 2 and 28 can't give me negative 10. And then 7 and 8 can't give me 10. So we got to dig a little bit deeper. And so eventually you should find that negative 14 and 4 multiply to give you negative 56, but add to give you negative 10. And you can always use your calculator, kind of trial and error, see which numbers work. And so once you've got your 2 numbers, you just need to write it in the factored form. Order doesn't matter. The big thing to remember is to factor out a GCF first. All right, and so if we look at this example 3, we've got a squared plus 3a minus 40. My leading coefficient is a 1. 1 times negative 40. That 1 doesn't have anything in common with anything else. So we've got negative 40 on top, 3 on bottom, and the 2 numbers that multiply to give me negative 40 are 8 and negative 5. And so we just have to write it in factored form. So a plus 8 and a minus 5. So then if we look at example 4, we've got x squared minus 11x plus 30. It does not have a GCF because we've got a leading coefficient of 1. And so we'll multiply that a times c, 1 times 30. Put that up top. Negative 11 goes on bottom. What two numbers multiply to give you 30 but add to give you negative 11? So think about it. Hopefully you got negative 5 and negative 6. All right, and so when we do that, all we have to do is write it in factored form, x minus 5, x minus 6. In example 5, we've got 3x squared plus 24x plus 45. We want to check for a GCF first. Since this a is a 3, we really do want to check for a GCF first. Otherwise, we're going to be multiplying 3 times 45, and that gets crazy real fast. So I do actually have a GCF of 3. And so I'm going to take that out, and that leaves me with x squared plus 8x plus 15. And so using that trinomial inside the parentheses, I've got a 15 up top and an 8 on bottom. My two numbers that multiply to give me 15, but add to give me 8, are 3 and 5. Keeping that GCF in front, I'm then going to write my factors. So hopefully that's not too bad. If we look at the next section of factoring, it is factoring a difference of squares. And difference of squares, if we break down just the name of it, difference means subtraction, and squares means we've got perfect squares. And so we know at this point that GCF can have any number of terms. We know that factoring by grouping has to have 4 terms, and when we're factoring a trinomial, that's got 3 terms. So difference of squares only has 2. So you can kind of think about that and logically think about it when all of your factoring problems get mixed together. So an algebraic term is a perfect square when the numerical coefficient, the number in front of the variables, is a perfect square. And so your numbers for perfect square is when you've got a number multiplied by itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 121, 12 144. And so you could keep going, but typically the ones I give you will just be up to 12 squared. 13 squared is 169, 14 is 196, but you can always use your calculator and check. You can check by taking the square root of whatever number you're given, and if it gives you a whole number, you know it's a perfect square. All right, so if we've got any of those numbers as a coefficient, and if the exponents are all even, and they need to be even because we're going to split them in half later. And so only even numbers can be split in half. So difference of squares always factors as follows. So if you start with your 2 terms with subtraction and even exponents, we're basically taking the square root of both terms. And one is going to be minus and one is going to be plus, but the rest is the same. So if we look at example 6, we've got x squared minus 16. Both coefficients, the 1 and the 16, are both perfect squares. They're both in my list. 2 is an even exponent, and so when we factor it, x squared, we're going to split into 2, so x to the first and x to the first, 2 cut in half. And then 16 as a perfect square, and its perfect factor is 4. One factor will be plus, one factor will be minus. And so one's plus and one's minus because it's canceling out that middle term. That's why we only have 2 terms of difference of perfect squares. So if we look at example 7, we've got 1 minus x squared, and again, there's a 1, so we've got some perfect squares, coefficients. And we've got even exponents, we've got subtraction, so difference of perfect squares. So perfect square factor of 1 is 1. And x squared, if we cut it in half, we'll have x to the first. 1 is minus, 1 is plus. Order does matter. We really are getting comfortable putting our x first in the factors, but when we've got difference of perfect squares and your number comes first, make sure that you keep the number first when you factor it. So in example 8, we've got 4 and 25 as our coefficients, They are both perfect squares. We have an even exponent of 4, 2 terms in subtraction, so it's difference of perfect squares. And so we've got to take the square root of 4, which is 2, split the x to the 4th in half, so we'll have 2x squared starting both of our parentheses. And then 25, the perfect square factor of that is 5. So we'll have one that's plus 5 and one that's minus 5. If we look at example 9, we've got 121 minus 25y to the 4th. Both of those are perfect squares. We've got even exponents, 2 terms, and subtraction. So the perfect square factor of 121 is 11. Perfect square factor of 25 is 5, and we'll cut that y to the 4th in half, so 5y squared. One is plus, one is minus. Example 10, x to the 6th minus 36. So we've got 2 terms, subtraction, even exponents, perfect square factors. Coefficients, I'm sorry. And so we'll go ahead and split that x to the 6th in half. So we'll have x to the 3rd, starting them both. One will be a plus 6, one will be a minus 6. And then example 11, we got 49x to the 8th minus y to the 10th. Both are, we got 2 terms, subtraction, even exponents, and perfect square coefficients. So 49 is a 7 as its perfect factor. And then we'll cut that x to the 8th in half. So 7x to the 4th minus y to the 5th, cutting that y to the 10th in half. One will be minus and one will be plus. Order doesn't matter. So one more thing, if you flip it over, we've got an essential question. What does it mean to solve a quadratic equation? So up until this point, all we've done is factor. If we add one final step at the end to solve, what we're going to find is actually the x-intercepts of a quadratic function. And we're going to get into that a whole lot later. So in example 12, if you've got a function f of x equals x squared plus 4x plus 3, and if you graph that onto Desmos, what you're going to find is that we get some x-intercepts at -3 and -1 with a vertex in between them. And I think it's at -2, -1 if I remember correctly. I might be wrong. And it forms a parabola. So you can double check with that and just find what your vertex is. And so we'll spend a lot more time graphing in the next unit, and we'll talk about all the characteristics. But that is the first method, the easiest method, the quickest method to solve a quadratic equation, especially when you get things like crazy numbers with decimals and all that stuff. So my solutions are the x-intercepts, and so I've got 1 at -3 and 1 at -1, 0. So, hello. All right. And so those are your x-intercepts. And so if we solve it by factoring, we've got x squared plus 12 equals 9 minus 4x. And the first thing we want to do is get it in standard form. So the big thing here is to remember that it equals 0. And so over here, we'll subtract 9 from both sides, and we'll add 4x to both sides. We just need it equal to 0. Make sure it's in descending order, and then combine like terms where you've got them. So when we do that, we get x squared plus 4x plus 3 equals 0. And the next step, factor the trinomial using any of the methods. So there's a bunch of methods out there. The ones that we did was just doing our x off to the side, and we need 2 numbers that multiply to give me 3 and add to give me 4. There's not a lot to choose from. You've got 1 and 3, and so we'll write it as our factors. And so up until this point on the front page, that's all you did and you could stop. Now we're adding a final step, and that's where you set your factors equal to 0. So we'll set x plus 1 equal to 0 and x plus 3 equal to 0. The important thing when you're solving is to set anything with a variable equal to 0. So even if your GCF ends up having an x. And then lastly, we will solve. So we'll have x equals -1 and x equals -3. And so you can write your answer like that. You can write it as a set using set notation. Or you can say, I know it's going to be a point, so it's -1, 0 and -3, 0. So 3 different ways to write your answer. I'm not picky, but you will see all of those when you've got problems. So it's good to know what they all look like. All right, last 3 examples. We've got example 14, n to the third minus 10n squared plus 24n equals 0. So hopefully by now you know that the number one thing that you want to check for is taking out a GCF. So in this one, we want to take out an n first. And when we do that, we get a trinomial with a 24, which is your a times c, and a -10. And you want to think of 2 numbers that multiply to give you 24, add to give you -10. -4 and -6 do the trick. So keeping that GCF on the outside, we'll have n times n minus 4 times n minus 6 equals 0. And what we want to do, anything with a variable, we want to set it equal to 0. So we end up with n equals 0, n minus 4 equals 0, and n minus 6 equals 0. And then we'll solve each of them. So just some simple one-step equations. So we actually have 3 solutions, and you can check it on Desmos. You can graph it and see where it crosses the x-axis. It's a cubic function, so it should cross 3 times. And so it crosses at 0, 4, 6. All right, then we've got example 15, 2x cubed plus 32x squared plus 189x equals 61x. In order to solve, we need it equal to 0, so we'll subtract 61x from both sides. So now it's equal to 0, and now we have to check for a GCF. So we actually have one. It is 2x. So we'll take that out of each of those terms. And then we'll factor the trinomials. So I need 2 numbers that multiply to give me 64, but add to give me 16. 64 is one of those perfect squares. And so I actually can use 8 and 8. So when we factor it, we can write it a couple ways. We can say 2x times x plus 8 squared. We can say 2x times x plus 8 and write it out twice. Either one is fine. So then, anything with a variable, we want to set it equal to 0. We only need to set x plus 8 equal to 0 one time. And we find 2 answers. So 0 divided by 2 is 0. 0 minus 8 is a -8. So my solutions there should be 0 and -8. Last one, x squared minus 81. It is 2 terms, it's subtraction, even exponent. 81 is a perfect square. So this one's a difference of perfect squares. X squared cut in half is an x and an x. Perfect square factor of 81 is 9. So we'll have one that's plus 9, one that's minus 9. And since we're solving, last step we want to do is set both factors equal to 0. We get 2 solutions, 9 and -9. And again, you can check that as well by graphing it and seeing where it crosses the x-axis. So if you've got any questions with that, shoot me an email. If not, you can go ahead and work on the next page for homework.